Now we're going to do some more examples with fractions. The first one says locate 5/6 on the number line. So because the denominator is 6, right, we're going to cut one whole into sixths. So on the entire number line, you would take each one of these wholes that are worth 1, and you would cut them all into 6 pieces. Now, I think the easiest way to cut something into 6 pieces is to cut it into thirds and then cut those in half. So, for example, we would cut, I'm just going to start here from 0 to 1. If I cut that into thirds, and then I cut each of those in half, that should give me sixths. And you could do the same thing with all of these. Cut them into thirds. Okay, that one wasn't as good. And then cut them into sixths. And you would do that for the entire number line because that is your fraction family there is going to be sixths. So then when you count, 0 of course is 0/6, and then you'd have 1/6, 2/6, 3/6, 4/6, 5/6, and then a whole would be 6/6. So you can literally in the numerators just count from 0 up through 6. So we're trying to find 5/6 on the number line. Well, 5/6 would be right there. So we found it. That's where 5/6 would be located. It's positive and it's smaller than 1. So if we wanted to find -4/3, the little family of fractions we'd be talking about there would be thirds. So we would cut one whole into thirds. And again, you would do this for the entire number line. So we've got, there's thirds, and then cut those into thirds, and cut these into thirds. You'd have to cut, all of them into thirds. And we're trying to go the negative direction, so I'm going to count the negative direction. So this would be 0/3, and then we'd have -1/3, -2/3. -1 would be -3/3, and then you can keep counting. -4/3, -5/3. If we went even more, -6/3. And do you see how -6 divided by 3 is -2? So when you're counting this way, you've got 0, then -1, -2, -3, -4. We're trying to find -4/3. So what I want you to see is that it's farther away from 0 than -1 is. And we've split the entire number line into thirds. So that's how you would work with fractions on a number line. So then what if you have some kind of a strange little picture like this one, where it says, in the following figure, represent each of the following as a fraction. So they give you this picture of dots, and it's 4 by 6. So I know that there's 24 total dots. I'll go ahead and get the total. And then there's like a rectangle drawn in there, and then there's a circle drawn in there. So let's see what they want us to do with this picture. Write a fraction that's the dots outside the circle as a part of all of the dots. The dots outside the circle as a part of all of the dots. Okay, so we want to count up, well, how many dots are outside the circle? Well, there's 24 total, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9 that are inside the circle. So that means there's 15 that are outside of the circle. So the number of dots outside the circle would be 15 as a part of all the dots. So it's giving you like the two parts of the fraction. So 15 out of 24, or 15 24ths, because this whole picture has been cut into 24ths. How about the dots outside the rectangle as a part of all the dots? Okay, so if you count all the dots that are outside of the rectangle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 as a part of all of the dots. So 12 out of 24. We can just leave it like that for now. And then the dots in the intersection of the circle and the rectangle. Okay, so we have to look at where does the circle and the rectangle, where do those intersect? Like which dots are sitting in both the circle and the rectangle? And it would be these 4 right here. So 4 dots as a part of the dots in the union of the circle and the rectangle. Okay, so now we really are talking about sets again. So intersection is like the overlap, so both. So that would be these 4. The union is all of the dots that show up either inside the circle and or the rectangle. So inside the rectangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then there's 13, 14, 15, 16, 17 that are inside the circle. So I'm just counting all the dots that land either in the rectangle or in the circle. So it's kind of like this. Anything that's there. And that turned out to be 17. So just a little reminder of intersection and union so you don't forget what those are.